Hello and welcome to the 3.1 Day 2 video. Now, in our last video, we went through and we found a bunch of features, really, of all these different problems, but we didn't actually graph any of them. So we're going back to those problems, graphing them. So I'll be graphing example 1, example 2, and then we're going to work through all of problem number 3. So let's get to it. So here's example number 1. We've already found all the features of this problem. I'm just going to remind you of a few of them. So we determined that the long run behavior was as x goes to negative infinity, f of x goes to negative infinity, so we're going to have a arrow pointed down here, and also that as x goes to infinity, f of x goes to negative infinity. So we have another arrow that's going to be pointing down this way. We have also determined that we have a vertical intercept, or a y-intercept, at 0, 4, so that's going to be up here, and that we have two horizontal intercepts, or x-intercepts, one at 2, 0, and the other at negative 4, 0. So this is all information that was already found in the previous video. If you don't remember how to do that, please go back and watch that video. Anyway, now on to the actual graphing. When we're graphing, we want to make a table. So I'm going to do that down below. We're going to make a table, and I'm doing this long ways. You can do this tall ways. And you want to make sure that you have enough points to really fill out the graph. So this is what I'm going to be looking for. I'm going to be looking for x values on either side of your x-intercept. So I'm going to look for negative 5 just to see the steepness. And I'm going to look for negative 2, positive 3 on the outside here. But then I'm also going to want all of the whole numbers in between those intercepts. So we're going to start at negative 5 because that is to the left of our x-intercept at negative 4. Then I want all the positive numbers till we get to our next x-intercept. Or pardon me, all the whole numbers, all the whole numbers, not positive numbers. Negative 3, negative 2, negative 1, 0, 1, and 2. That's our next x-intercept. And I want to go 1 past that just so we can look at steepness. So these are all the numbers that I want to take and plug into this equation to find out their y values. And you can just do that on a calculator. The cool thing is that we already know a few of these. So we know that there's an x-intercept at negative 4. We also know that there's one at positive 2. And then we know that our y-intercept is at 4. So we already know some of these. In the normal school days, I would assign each table group a number to plug in, and we'd all come up with it together. But instead, I'm just going to take a shortcut and just tell you what all the y values are. So at negative 5, the y value should be negative 3.5. Now, I just want an exact answer. So in this case, 3.5, that is an exact answer. However, if you wrote negative 7/2, that is okay. At negative 3, we have 2.5, or 5/2. Then we have 4 and 4.5, or 9/2. At 1, we have 2.5, or 5/2. And at 3, we have negative 3.5, or negative 7/2. So I'm going to take a moment and plot all of these points on here. So let's see. We're going to have a point. Oops. 4.5 and 1. And we have 2.5. And then we have negative 3.5. Okay. So once I connect all my points, see, I have a pretty nice looking parabola. Both of my ends are facing downward. And that's all we need to do. So let's take a look at example number 2 and do the exact same thing. This is example number 2, and some features we have already found about this function is that, for instance, the long run behavior, as x goes to negative infinity, f of x goes to infinity, so we have our left arrow pointing upward, and as x goes to infinity, f of x goes to infinity, so we should also have our other arrow pointing upward. Other features is that the vertical intercept, or the y-intercept, is going to be 0, negative 2.5, so it's about right there. Just do the best that you can when graphing decimals or fractions. And then we have 3 x-intercepts or horizontal intercepts. And I'm actually going to list them out because for our horizontal intercepts, we have a horizontal intercept at -1, 0, and this intercept actually has a multiplicity of 2. Our other intercepts are, let me take a look, -2, 0, and 5, 0, both of these with multiplicities of 1. And it's important to recognize this so we can see how are we supposed to graph this. Now again, I take a look at this. I'm going to, plot my important information. So let's see, that's -1, that's -2, and 5. So I have all the information. I want to make a table and list the points starting my x value over here and going all the way through all of my whole number x values up to 6 in this case because it's the most right value. I am going to add in 1 decimal or fraction x value, and that's going to be right here at -1.5, just because there's 0 at -2 and a 0 at 1, and I didn't know what happens between there. Is it supposed to go up? Is it supposed to go down? Where is it supposed to go? So this is one of those cases where I would actually have a fraction for that. So let's make a big table of x all the way across the page, f of x. So we'll start at -3 since that's to the most left of -2, and then -2, and then here comes that decimal of -1.5, and then -1, 0, 1, 2, 3, 4, 5, 6. Longest table ever. Okay, so what do we already know? We already know that at -2, -1, and 5, those are going to be x-intercepts, so the y value is 0. And then we know that our y-intercept is -2.5. So if you'd like to pause the video, take a moment, plug these numbers into the equation just to make sure that you know how to use your calculator properly, you're using your negative values property, and make sure that you're being really careful with this right here, that multiplicity of 2. A lot of people will miss that. Please don't miss that. That's going to change some of your y values. Well, if you paused, welcome back. If not, thanks for sticking around. I'm just going to tell you what the y values are. So at -3, it's going to be 8. At -1.5, it's going to be -0.2, so that tells me that it did dip downward. At 1, that's going to be -12, and -27, -40, -37.5, and then at 6, it's going to be 98. So I take a look at all of these y values, and I go, you know what? They are not going to fit on our graph, which only goes up and down to +8 and -8. That's okay. I'm going to show you kind of what we would do in that case. In the next example we're going to do, I am going to rescale the y-axis just so that you can kind of see what that looks like. But let's connect all of our points. Let's plot everything that we have. And thank you for your patience while I do this. Please feel free to fast forward. So let's see, we're going to have a point here. We're going to have a point down here. And these are actually all the points that we're going to have because everything else goes off the graph. So I know that we're just going to kind of play connect the dots. So I know that over here at -3, it's going to go up, and I'm going to go through and trace everything that I have. So I'm going to come down here. It has to connect to this x-intercept, go through, come back up, and it has to bounce down here. And I know that it has to bounce down because at my horizontal intercept of -1, 0, we have a multiplicity of 2, which is that bouncing shape where it looks kind of quadratic, which is why it went straight through here and then bounced around and came back up. And we're just going to continue that downward here. It gets really close. And then I know it's supposed to come back up through here. I'm going to make this really narrow. There we go. And there's my graph. So we got a whole big old blank spot down here, which corresponds with the -27, -40, and -37.5. And then again, 6 goes all the way up to 98, so I'm never going to quite hit that. But this is what our graph looks like. And again, you can double check. I see this goes straight through over here, with a multiplicity of 1, and then we have a bounce right here with a multiplicity of 2. So that was going back to our previous problems. Now we're going to do one problem all the way through. Example number 3. So we are going to find all of its features and graph it. So the first thing I'm going to look for here is the degree. Now this is going to be a little bit tricky because I can see over here we have a multiplicity of 3, so we're also going to practice graphing that. We have a multiplicity of 1, and then we even have another factor, which is right here, the x by itself. And x by itself, you can also write that as x plus 0 if you want. It means the same thing. But if you see an x by itself, that is a root at 0. And we'll talk about that. So the degree here, if I add up all of my multiplicities, 3 plus 1 plus 1, that was going to give me 5. So we have an odd degree, meaning that our ends are going to be going the opposite way. And for our leading coefficient is -1/2, meaning that our ends are going to be going in opposite directions. But it means that the left side will be facing up and the right side will be facing down. It sometimes helps me outside of my graph to just like say, hey, this is where the ends should be going. So by the end when I'm graphing, if that doesn't happen, I know I've made a mistake somewhere. This will also help me with the long run behavior. Which is describing what those arrows are doing. So as x goes to, or approaches is another way to say that, -infinity, referring to our left arrow, f of x approaches infinity because it's moving up. And then as x approaches infinity, or our right arrow, f of x approaches -infinity because it's pointing downward. So sometimes drawing those arrows first can help kind of direct where you're going. Next, we're going to want our maximum number of turns. Which is going to be 1 less than our degree, so in this case it'll be 4. And then the maximum number of zeros, we still want to list that, that's going to be the same as the degree. So that's the maximum number of zeros, but I do just want to point out we only have 3 in this case because one of them does have a multiplicity. So that's okay if they are different. Next, let's go for our vertical intercept, also known as our y-intercept. Vertical intercept. So that is when we are plugging 0 in for x. So f of 0 is going to be equal to -1/2 times 0 times 0 plus 3 times 0 minus 2 cubed. Now normally we go through step by step and we solve this. However, we're multiplying the whole thing by 0, which means no matter what, it just becomes 0. So feel free to write that as 0, 0. Please write that as a point. And that's kind of nice because we know that when we do our horizontal intercepts, that this is going to be one of our horizontal intercepts as well. So let's do that. Let's come down here. So let's see. I have to write kind of weird or else my wrist hits the mute button. So I'm sorry that my handwriting gets worse and worse. So for the horizontal intercepts, that's when we set the entire equation equal to 0. So in this case, that'll be 0 is equal to -1/2 x times x plus 3 times x minus 2 cubed. So we can say, all right, f of x is equal to 0 when any of these factors are equal to 0. So when x is equal to 0, when x plus 3 is equal to 0, when x minus 2 is equal to 0. So even though x minus 2 has a multiplicity of 3, when I'm finding my intercepts, I can just ignore that. We'll be listing those later anyway. So we have those. Now when we list our actual zeros, that's the x is equal to format. So this is x is equal to 0. That just stays the same. We have x is equal to -3, and x is equal to +2. So when we write out the actual horizontal intercepts, or x-intercepts. You ever write a word so many times it just loses all meaning? That's how I feel about the word intercept. So let's write these as points. So this will be 0, 0 again. Oh, I meant to do this in red, so it would be, yep, there we go. I'm not gonna record over that. That's just gonna be there. All right, so it'll be 0, 0. It'll be negative 3, 0. And that will be 2, 0. And then next we will list our multiplicities, or like the behavior around each of these points. So for us, that'll be a multiplicity of 1, a multiplicity of 1, and then a multiplicity of 3. Ooh, I just got an email. So now we get to figure out how do we graph that. Let's make a table. I'm going to come over here off to the side, and I'll just create an up and down table this time. So let's plot the points that we already know. So let's see, we already know that we're going to have 3 horizontal intercepts, 1 when x is 0, 1 when x is negative 3, and 1 when x is 2. And then our vertical intercept is the 0, 0 point, so we're good there. And I know that when we make a table, we want to start 1 left of the most left intercept and go all the way through all of our whole numbers until we get over here to 1 to the most right of our most right intercept. So that means we're going to start at negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Oh, that was almost the perfect length. Okay, so from our table, what do we already know? We already know our 3 x-intercepts, which is very nice. And that's about it. So feel free, take a moment to pause, plug in all these other numbers into the equation, and see what you get. Welcome back. I'll let you in on what the answers were. So at negative 4, the y value is 432. At negative 2, the y value is negative 64. At negative 1, the y value is negative 27. At 1, it is 2. And 3, it is at negative 9. So this is quite an array of y values that are definitely not going to fit on here. So something I'm going to do is I'm going to rescale my y-axis. And I noticed that we have one that goes up to 64, 27, so multiples of 10 seem to be good. So I'm just going to stick a 0 on all my y values. And now instead of having every y value block be 1, it's now 10. Beautiful, genius, excellent. Okay, so let's plot these points. So I'm still not going to be able to fit the y value of 432 on there. That's okay. I can fit the y value of negative 64 when x is equal to 2. It's going to be about right there. Get as close as you can. This is about times. So for instance, when the x value is negative 1, the y value is negative 27. I know that's going to be in between negative 20 and negative 30, but closer to negative 30. About right there. And then let's see, we have the value 1, 2, which will be like really close. It'll be like there. And then 3, negative 9, which is really close to negative 10. Okay, so we have these values. So let's see, I know my left arrow over here is supposed to be sticking up, so I'm going to start it somewhere over here. We can't quite reach that 432 for a negative 4, so I'm going to start it like here-ish. And now we're just going to play connect the dots. So I'm going to work through here, all the way down. So I'm hitting this x-intercept, and it's going straight through, going all the way through and coming back around. It's going straight through this intercept, coming here, and now we have our multiplicity of 3 at 2. So that's a multiplicity of 3, and this goes all the way down here. So my end behavior looks correct, and I should have the correct behavior or multiplicities around each root. Now you might be able to say, Ms. Twain, I know that goes straight through, that goes straight through. I have no idea what's happening here. If you're not sure, if you don't think if it's clear enough, if it's kind of the points are too close together, you can always kind of draw a zoom screen. So you can always say, hey, that right there, it's supposed to look like this. So at 2, it's supposed to look like this. So if you ever want to do that and say, hey, I want to make sure you know that's what's happening there. That's okay. You can kind of zoom in there. Anyway, that was one full problem. We have found all of the features. There we go. There we go. We have found all of the features. We made a table. We graphed it. This is absolutely beautiful. This is everything you need to know when you're given an equation to a polynomial. The next video is going to be focused on if you're given the graph, how do you find the equation?